Hey everybody, I just made sure I was unmuted this time. Okay, so you guys should be able to see me now in all my glory. Um, what I wanted to talk to you about today, just for a minute, I got a new toy here actually a few months ago now that I couldn't use it. A document camera that I'm going to show you, kind of a graph in, just a little bit, so we can talk about graphing, which we're going to be doing um, in the kinematic experiment, and then also some future experiments too. And I want to give you a little heads up on something. Let's see if I can make this work more or less embarrassingly. Okay, so what you're seeing there is a kind of a skewed view of my notepad with a rudimentary graph on it. And if I can draw on this a little bit without really shifting the paper around, what you're seeing here is the X. I can't tell where the pad is now. Where the X is in X, and that should be X or T. Yeah, it is X or T. I can't write that well either, so I don't do this very often. X or T in this case, this is a horizontal axis or time. Time is usually plotted on the horizontal axis as well, and it's kind of a graph anyway. There'll be times when it isn't, but we're going to do this today because what we're doing here, we're going to plot as a horizontal distance changes, there is a possibility of something else changing. And my badly drawn y up here, that's we're gonna change x in this graph we're talking about. As we change x in this first one I'm talking about, that's going to be well, you know that equation, y equals mx plus b, where m is the slope and b is the y-intercept. The y-intercept here is down here like this. Would be down here. And then m is the slope, so that's just a function of what the line is, where that goes. But the y value then depends on what the x is that you put in the equation first. So in this case, x is the independent variable. That's the one you put in first. Y is what ends up as a result of that. So that becomes the dependent variable. That'll be important, or those ideas will be important later on when we're talking about some different graphing. And you've got to plot one quantity versus another quantity. And I don't want you to plot them backwards because it doesn't make any sense when you do. And some of the interpretation of that is hard to do when you plot them backwards. And some students, just because they're, well, like me, left-handed or something, they get them wrong. Um, the other way thing it might be besides position might be time. But time is not something that we control, right? That's just something, time just goes on and time just happens. So as time in this case, it increases, then maybe on our plot what we're doing, we're going to try to find the position on a vertical axis of where time is, or pardon me, where this object is. You know, I'm just kind of making it up as I go along. And where this object is as a function of time. That's what you want to think of when you're changing these two variables, changing one variable, I'm sorry. You're going to be changing one thing and the other item will change in response to that. So as time goes on, the position might change because of time. Might not too, but at least that's what it's dependent on time. In these kinds of graphs, that's what we're talking about is those kinds of changes. Okay, I'm gonna go back here and get rid of this. Great. Hold on. There, I got it finally. I just push all the right buttons. Okay, that was my little few minutes of confusion for you. I hope you found that somewhat entertaining and maybe even educational. The other graph that's on here, or the other movie that's on here, is much more professionally done, and that's about uh, two variable systems. That's what I'm talking about. This. Only mine is much less professionally done. If you have any questions, just email, text, or call me.